Thanks for coming. I'm the moderator, so I guess I'm saving some energy to have more debate because I was told that this needs to be a spicy, controversial section. And I already saw that coming because there are two professors here and there are two people who drop out or technically drop out. So it's a pretty interesting contrast. So I guess I will just probably start with probably a 30 seconds introduction, self-introduction for each of us. And maybe I can start with myself. I'm Tongyu Ma. I'm assistant professor at Stanford. I also was a CEO and co-founder of a company called Voyage AI, which was acquired by MongoDB 6 months ago. So I'm a chief AI scientist at MongoDB. So I work on large language models, machine learning, deep learning, some theoretical aspects of them. These days, RL, reasoning models, so on and so forth.
Hi, I'm Karina Hall. Thanks so much, Tony, for a great start. Founder, CEO of Axiom. At Axiom, we are building a self-improving, super intelligent reasoner, starting with an AI mathematician. The future frontier models, to me and to us at Axiom, are models that are able to generate correct, no hallucination outputs of very complex problems. And these models are able to propose new questions, new hypotheses that are worth pursuing, and then generate grounded proofs that answer those questions. This is a self-improving loop, and this is something we at Axiom strongly believe in. In mathematics, you have conjecturing, you have proofs, you first expand your knowledge base, and then you ground them. This is what we believe to be the frontier model landscape. Thank you.
I'm Andy. I actually thought about being a professor. When I entered my PhD, I thought I'd be a professor, but then GPT changed the world, and here we are at one of the places where I believe we are changing the world. So at Anthropic, I've worked on a bunch of stuff. I've been there for a couple years or so, a year and a half. Nowadays, our work is focusing a lot on scaling up RL, and I do a lot of work on making sure behavioral regressions, the model is usable, nice, helpful, and generally a good collaborative partner. And so, in academia, we spend a lot of time thinking about the beautiful theoretical nuances of problems, and then when you work on one of these large models, you see how quickly these things break down when you get your hands dirty. And so I'm excited to talk to the professors on stage about how we can meaningfully bridge theory and practice into something usable.
Hello, everyone. Ramesh Raskar, associate professor at MIT, and also lead this project on decentralizing intelligence called Nanda, Network AI Agents in Decentralized Architecture. And a lot of our background, my group has been a pioneer in the earliest AutoML, earliest privacy-preserved machine learning, different way to knowledge, different way to price knowledge and data, and so on. And a lot of theoretical stuff, I know, a lot of papers. But I think now is an exciting time to see how we can think about creating intelligence, not by centralizing it, but by decentralizing it.
Yep. I guess my first question, which is probably the least spicy one, so is pretty much what the title of this session is about. So I guess we all know that now AI is super hot. I think the theme of this year seems to be about agents, right? So I guess because this is about powering the next leap of AI, let's say agent is the current leap, right? So suppose you exclude agent from the possible option set in some sense, right? Like, of course, agent has multiple definitions. What is the next technology that will drive us to the next level of AI, if you have to say one? Maybe I would like Andy to start.
Yeah, I think it's been no surprise in the field that the big scientific frontier driving the first generation of language models was pre-training, downloading large-scale, internet-scale databases, and training on next word token prediction. And in the last year and a half or so, that paradigm has entirely changed into the realm of reasoning models. So agentic systems that develop and reason and think over long time horizons. And I think right now, we're not quite sure exactly how far we can push this frontier. But I think at Anthropic, we have some ideas how we could scale this up meaningfully into agentic systems that no longer just think about the next turn or a couple turns after, but really reason over long horizons. agents that can operate in your software window for hours at a time. Claude Code, who here has used Claude Code? Really fundamentally like a new way of programming and interacting with your machine. And so for us, we're excited about continuing to push out reasoning frontiers, continuing to scale up RL, and we'll see kind of when that paradigm shifts, because we'll invariably invent some new ones.
Yeah, I know Ramesh probably has some kind of like controversial statement about this question. So I guess I will let you to talk about it.
So I think there are different ways to think about it, right? If you go all the way to how Marvin Minsky talked about the society of the mind, the aspect was there's not like a single brain, but there are different aspects, and they all work asynchronously and autonomously, and from that emerges the intelligence that we experience. And that's been true many times. As a society, it's the same thing. If there's a CEO of a company, we don't try to make the CEO the smartest person in the company, like highly centralized intelligence, but we say the CEO is more of an orchestrator, the best orchestrator, but the intelligence is actually all the smart people in that company. So I think let's consider this possibility that actually we might be doing this completely wrong. The fact that we have centralized all the data, centralized all the compute, centralized even all the talent, is that the right way to think about the intelligence globally, or should be done differently? And so a possibility is that the right way to think about intelligence is we actually create many micro AIs that are all over the world, and they have their access to local tools, local data, local context, and as they talk to each other, kind of global intelligence emerges. And if you think about big companies, actually that's what they're doing. They're not acknowledging it, but instead of creating one large model, they say, oh, maybe it's a mixture of experts. Oh, maybe it's not a mixture of experts, but maybe it's reasoning where I'm going to break out of the task. So they're decentralizing their definition of intelligence already. And that's just a continuous slope to actually what we're talking about, which is there's going to be micro AI all over the world, and that's how intelligence is going to emerge. And that's going to solve many issues. Energy will not be a problem. Risks of superintelligence will not be a problem. And all the innovation and benefits will be highly democratized.
So I guess the answer is that we need to kind of like decentralize the AI and to have many, many AIs working together.
Yeah, that's going to give us higher quality intelligence than centralizing it.
Got you. Maybe I'll move to Karina.
Yeah, I think the frontier, as Andy said, is on reasoning models. We have seen coding models having incredible performance boost. Reinforcement learning in the domain of coding has been so wonderful because coding is a verifiable domain. You can have a program and you can run it. You will either see a check mark telling you that the code has run, has executed, or you will see some error message. Now, the question of reasoning is always math and code. And I'm just always curious about how do you turn other domains into also verifiable domain. And for math, you can rely on programming language and proof assistants like Lim4 to check the code. In other words, you can turn every single math problems and solutions proofs into the computer version, like the computer code, and then get the same incredible success that you have seen in RL for coding. So we at Axiom are quite excited about that as the next frontier of AI, which is verified superintelligence. We want to build self-improving systems in the verifiable domain that can let the model reflect on the mistakes it has gotten wrong and then reflect on what it has gotten right, and then have multiple of them interact with each other to continue improve on the performance. This is what we believe to be the next leap of AI.
So I'm trying to reconcile some of the ideas here, right? So I guess Ramesh's point is you need to decentralize and have many AI. And in some sense, I think that rhetoric was probably there 2 years ago as well. And I think I remember, I went to some of the events and they say, oh, there will be like 1 million different models there as opposed to just the 3 models from the frontier labs. But after 2 years, I think that I would say probably didn't really happen that much. I think there are probably a handful of number of models in the OpenAI, Anthropic, XAI, and a few open source models. Not even necessarily Llama these days, I guess, right? So what changes, for you to believe that there will be more and more, things will change, in the future compared to the past, which I probably would characterize as more like one AI that does many, many tasks, right? So like Anthropic's model can do many things. Right. OpenAI's model can do many things.
Yeah, let's make a distinction between models and intelligence. I think maybe there will be only 2 models left in the world. That's perfectly fine, but how you use them will be very, very different. I mean, right now we're kind of in the mainframe era of AI. So back in the 80s, even if you had to use a calculator, or word editing, you would, over a modem, you would connect to the mainframe and let them help you with the calculation or word editing. And that's what's happening now. And then once we moved from the mainframe to the PCs, we don't need to do that. You can just download Microsoft Word once, and you can do whatever you want to effectively train your Word, Microsoft Word, because you're writing your own documents and so on. So the Word that you have on your PC is very different than the Word that you bought, right? Which has all these documents and so on. And so even if there are only two makers of models, that's perfectly fine, because by the time you use them, first of all, the models will be probably sub-gigabyte, maybe sub-100 megabytes. They'll fit on your phone. They'll fit on your laptop, and it'll be even better than the models we have today, right? And that's already happening, the tiny ML. And so all the models will be very tiny. I think the models will be highly commoditized. I think the possibility is that the big model makers will get out of the business of creating models, because as you know, the token costs are decreasing by a factor of 100 every year. It's a race to the bottom. So I think the real value is going to come because all these models are either distilled or freshly trained for very minor tasks, whether it's health or legal, my own life, my own calendar, my own email, but that I'm running locally on my own machine. And then when my agent or my AI talks to your AI and other scientist AI and so on, new intelligence emerges out of that. So I'm not saying there's only like one Microsoft Word or another word processor, and similarly will buy things from these model makers, but they'll be $10 a pop or something like that.
Got you. So I guess you make the point that some of these model companies, probably the models will be commoditized, right? So and the cost of the tokens will be cheaper and cheaper, right? So I guess maybe I would move to Andy. So how do you respond to that? I think this probably wouldn't be necessarily good news for Anthropic, assuming that's the real what's going to happen. Or maybe I'm wrong on that as well. So.
Yeah, look, like Anthropic is one of the frontier companies building the technology, and part of building the technology involves investing in, on the order of, billions and billions, potentially even trillions of tokens for training. And not only is this training data, this is also, the resourcing and the talent and the labor required to ensure the training runs go well. And not only do we care about training runs going well, we care about making sure usage of the model goes well, right? Like in a world where we have agentic systems willy-nilly floating around, I remain a little concerned about the future of safety on the internet, right? Right now, I think a lot of misuse and abuse of agentic systems at scale is limited in part because we have good monitoring systems on these agents. And so I think it's one of these things where I challenge us to think a little bit about what a world in which truly commoditized AI and agentic systems autonomously floating around the internet actually looks like, and what are the right means of control for thinking about the best way to safely emerge in an ecosystem, right? The analogy I like to use when thinking about, like safety and sustainability for these systems is, we like designed the network of roads to fit with the cars that we have today, right? We invented the engine, and the engine goes a certain speed, and we're like, oh shoot, like to make sure people don't run into each other and kill people, like we need to have seat belts and road infrastructure and stop signs, and all of these things emerged as a part of an ecosystem of understanding how systems like cars engage with each other. Right now, we're not sure the speed at which agents can move, and so it's hard to design the ecosystem around which we'll deploy them. And so partially, I think this is a difficult question to answer because we're trying to predict ahead to a future that we don't quite understand. And so I think Anthropic's view has always been we are building intelligence, and part of building intelligence is studying how humans use intelligence. And in order to understand how humans use intelligence at scale, that will help inform of what the world of agents looks like.
Yeah, so I think another, maybe my controversial view of this is that, I think even though the token the token price is dropping dramatically in the last few years, most of these are driven by the smaller models. The GPU cost is not really actually lower, right? It's probably, H100 price is always like $2 an hour, more or less, right? So in the last few years, and even A100 didn't get cheaper and cheaper over time. So, and the new kind of
because that's a monopoly.
That's a monopoly. But maybe there's some physical constraints on how, they have margin, pretty big margins as well, but it's not like the margin is 99%, right? The margin is probably 70%. So maybe there's some physical constraints. I don't know. Yeah, but that's my controversial view about this. Maybe we can move to, I guess Andy mentions a little bit about like a commercialization and also how users are using AI, which is kind of like relates to commercialization of AI. So I guess I want to move back to Karina, and I think one of the kind of like, my question about Axiom and some of this, verifiable system or verifiable models is that how do you commercialize them? Maybe you can comment on that a little bit.
Yeah, for sure. I think we are entering an era of mass intelligence. As the price of reasoning become more and more elastic, there will be more and more unexpected use cases and markets that we haven't actually had the tools to unlock. So in a way, demand is bounded by supply. Like if you think about it, I have 100 AI Terence Taos in this room. What kind of problems can that sort of super intelligence help us solve? Math is the foundation of so many things, from physics, engineering, to you could argue that computer science or a lot of the algorithms problems that we're solving are based on math. Like if you solve a really hard partial differential equations, like what happens if you solve Navier-Stokes? Well, I guess then you will have like, a nuclear reactor. Like the incredible power of mathematics and fundamental science leveraged by AI to be scaled and to be kind of applied at an incredible, unprecedented speed to all the applied sciences. That is what mass intelligence means. Like, what does it mean for a cloud compute provider to have AIs as capable as Facebook engineers being paid $2 million a year to solve those mundane IT, like optimization tickets, and you only pay those AI systems, say, $0.67 each year? Like, what does it mean for a hedge fund trading in a market that's relatively small, say, 8 million total trading volume, but you can afford quant traders of minimum pay 12 million a year, but that in the form of an AI, and you just pay that $5 each hour. Like what do those mean? And I try to ask a lot of the sci-fi authors I know in my network about that question, and I think I asked Neil Stephenson that, and he said, well, don't dream toward one focused angle, dream broadly. And I think there are just so many things in existing market, if you look around the corner, and in new markets that you could unlock if you have really super intelligent AI.
Yeah, related to this, I think I also have a controversial probably statement. I think from my experiences, I feel like even if there's no more frontier models, let's say the capacity of the models, the intelligence levels of the base models is not going to improve in the next 10 years. I feel like we're still going to have a great 10 years of commercializing AI just because I feel like the speed of the commercialization is bottlenecked by humans now, just because humans are not willing to adapt to the new world. I think I can give an example. For example, I just recently bought a Tesla once I got some money from the acquisition. And I always thought that I wouldn't use the Tesla because the gear, you change the gears on the screen, which sounds like, not quite right to me, like for someone who is still using the automatic, the standard gear. And then, but after I bought it, after 2 months, I feel like, oh, this actually makes so much sense because I don't even have to change gear now. Like FSD, you never need to change gear. You don't even have to change to parking because FSD will automatically change it to parking mode. So I start to love it. And I reflect on the past. I feel like, oh, this is just because I was kind of like too used to the old way of doing things and cannot just adapt to the new way of using AI. And the same thing happens for many cases. For example, we have to encourage our engineers a lot to use the code assistant tools at the beginning. And then once they use them, they get used to them, they love the code assistant tools. But at the beginning, there's always resistance. I'm not sure whether, is that a controversial statement, or is that, how do you respond?
I think that the commerce part of it is an important one. Imagine if you had stayed in the mainframe world versus the PC world. They're only like IBM and DEC and Cray and so on, and we just connect to them and get some compute, which is what's happening right now in AI, as opposed to the PC world. And if you look at the revenue made by PCs versus the revenue made by the web, is very different. And the same thing is now, the point you made for scientific knowledge, there's a talent all over the world, but if they can create their own AI, me as a professor, if I can create my own AI and participate in your network at Axiom, we'll be able to solve the scientific problems much faster than trying to create a model at a single place and see if we can try to solve the biggest problems of our society. At the same time, my agent could start charging you like $5 a minute or something like that. And there could be a marketplace for this. So I think the agentic commerce is going to be this ridiculously amazing opportunity, but that's going to happen only if the agents are created by each of us, as opposed to they're created by one company.
I do want to use Tommy's example of the Tesla. I think in the consumer use cases, we have seen AI getting incredibly good. But what about like B2B? I think in enterprise and like other business, in high-stakes situations especially, so complex systems that any tiny mistake is going to cost billions of dollars of loss. In those settings, the main capability of AI is not to be trusted yet because we have a verification problem. And the outlier capability, like really solving Navy stroke, that has not been unlocked yet. So I think there's like a pretty long way to go, but also recognizing that in day-to-day, we are at a place where probably we can enjoy the prosperity due to the AI progress at the consumer level.
But it's like Norton antivirus. When people had mainframes, they didn't have to worry about viruses, to your point about safety and so on. But when PCs came around, there's a cottage industry of people building antivirus solutions. And so similarly, you'll have cottage industry of people worrying about safety, security, bias, evaluation, and so on. So it's better that a whole bunch of people are solving that problem as opposed to people in one company trying to figure out what it means to do safety and compliance.
Regarding the safety aspect, once I'm in MongoDB, I'm exposed to some of the enterprise settings. And I found that actually, so for example, one of the reasons why we don't use the code assistant tools is because people are worried that they will automatically change the code base, right? But actually the solution to that is that you just let people to review and commit, right, in the short term until Cloud Code or Axiom or some other kind of companies make a fully automated code assistant or code agent, right? So that's the most logical thing, but people just say, oh, there's a risk, down the road, and so we don't do it. So I have to spend a lot of effort to work with humans to be able to kind of like use some of these assistant tools inside the enterprise, which make me think why humans are the bottleneck for commercialization to some degree. Anyway, we only have like 1 minute and 30 seconds, so I guess maybe my last question, is a little bit selfish, for me, who is coming back to Stanford after this 2 years journey and thinking more about research. So I wonder whether, if you want to, I wonder what is the research topic that you wish that academia can do for your company, but your company doesn't want to do, shouldn't do it, right? Like and maybe this is something like 2 years ahead or 3 years ahead, because academia, you cannot work on like 6 months project, right? So I guess this is mostly for Karina and Andy.
Yeah, I think this dovetails really nicely off of your previous point, which I don't think is that spicy of a take, and I personally agree with. If intelligence plateaued today, if it is not, but if it were, I still think the large economical and social and scientific discovery capabilities of models, I think we're nowhere close to actually unlocking. So if it were up to me, I would say, we spend a lot of our time squeezing intelligence out of large-scale runs. We don't spend a lot of time studying how people want to use them. And so to the extent that, I think in academia or in tangential fields, thinking about what is the ideal collaborative system or not collaborative system that we actually hope to be benefiting various applied fields is probably the most important question today, right? It's not like the model is going to make a drug that is delivered to my doorstep, right? Like we're very far away from this type of like fully autonomous process. There's going to be a human person that needs to experiment in a lab somewhere with actually doing the testing in like material science or whatever to like make a drug that saves us from whatever, some terrible fate. And so I think really seeing where models plug in gaps and where humans can leverage their knowledge, I think that would be very important today.
Yeah, I think at Axiom, we really want to see verification playing into a lot of the fields and domains that may not be ready yet. So I think academia is a perfect kind of sandbox. And for example, there is this library called CSlib in the language, in the programming language of Stanford that people are developing, I think, right here at Stanford at Clark Barrett's lab. So I think projects like that, trying to kind of apply formal verification into different domains, even when it's really, really early days with incredibly scarce data that you can't really train any model. So those are interesting directions that we would like to explore.
Sounds great. I guess my summary is that you want the academia to do early stage kind of exploration for more verifications, and Andy wants the academia to do user studies for your company so that you don't have to hire the user researchers.
Oh, we can do it too. We're doing it too, but I think academia is positioned in a place to be slightly less biased. So.
Of course.